In this video, we will discuss the concept of inverse of a matrix. By definition, if A is an n by n matrix, then there exists an n by n matrix B such that the product of A and B is equal to the product of B and A, and that is equal to an I sub n. Now, I sub n here is what you call an identity matrix. And we should be familiar already kung ano ang identity matrix. No? Ang identity matrix ay isang square matrix na ang elements doon sa main diagonal ay puro 1 and then the rest ay puro 0 above and below the main diagonal. So it's I sub n, yung n na to ay pertains to the order kasi A and B are both square matrices. No? Note that the inverse of the matrix only exists when your matrix is square. So kung hindi square yung matrix mo, no, 2 by 2, 3 by 3, 4 by 4, and so on, no, n by n, then automatic the inverse will not exist. Now, if A has an inverse, which is matrix B, for example, then B, okay, should also be n by n. So the product, okay, is an identity matrix. And as you can see, although in general, yung product A times B is not equal to B times A, kung ang A and B are inverses of one another, then okay, pwedeng lumabas na commutative siya. Okay? So yung A times B is equal to B times A. Yung identity matrix natin, no, pwedeng let's say I2. Yung I2 natin, ang itsura niyan would be 1 0 0 1, or yung I3 natin 1 0 0 0 1 0 0 0 1, or yung I sub 4 is 1 0 0 0 0 1 0 0 0 0 0 1 0 0 0 0 1, and so on. So ganyan yung pattern kapag identity matrix. Now yung inverse matrix natin, B, can also be denoted by the innotation, no, by symbol A raised to negative 1. So this one is or denotes, no, the inverse of a matrix A. So pwede rin nating isulat itong definition natin as A times A inverse is equal to A inverse times A is equal to an IN. Now if A is or if A has an inverse, then we say that A is a non-singular matrix, or we can also say na A is an invertible matrix. So non-singular or invertible, ibig sabihin may inverse. Kung walang inverse si A, which is possible, okay, possible na yung matrix natin ay walang inverse, then we say that the matrix is singular or non-invertible. So in getting the inverse of an n by n matrix, we start with ano muna, no, 2 by 2 matrix, kasi ito yung merong tayong shortcut. Okay? So for a 2 by 2 matrix, if A has elements A, B, C, D, and the inverse of A exists, then we obtain the inverse as follows. So what we have here is a scalar muna, no? Parang you have your matrix which is composed of A, B, C, and D as the elements, and then yung inverse natin, ang mangyayari is parang pinagpalit natin, yung interchange yung A and D, no? Yung pwesto ni A and D, and then ni-negative natin si B and C. Okay? So yun yung nangyari sa part na to. And at the same time, we have a scalar here, okay, multiplied with that matrix. Now itong scalar na to, okay, parang you can imagine it as being the product, okay, of this one, A times D, and then minus this one, C times B. Okay, so diagonally, no, minultiply natin yung ating elements, and then we get the difference. Okay, so ito yung part na to, okay, nung ating inverse. So what we will do is we will just multiply, okay, this matrix here, okay, with this scalar, okay, the 1 over AD minus CB, para makuha natin yung ating inverse of A. So for example, you have this matrix A containing these elements 1, negative 2, 3, and 4. Following yung ating kaninang formula, no, or yung ating yung pattern, no, ng ating inverse, A inverse is equal to 1 over, so we will multiply this pababa muna, no? So 1 times 4 minus, multiply natin paakyat naman pag ganun, 3 times negative 2, and then multiplied by the matrix. Okay, so yung A and D ay magpapaliktad ng pwesto, and then yung C and then yung B ay magne-negative yung sign, or magpapalit yung sign. Okay? So with this, okay, we simplify further. Okay, yung scalar natin dun sa labas is 1 over 4 minus negative 12 to, magiging plus 12, no? Then multiplied by 4 to negative 3, 1. And so the A inverse is equal to 1 over 16 times 4 to negative 3, 1. When you multiply 1 over 16 sa loob, that will give you 4 over 16, 2 over 16, negative 3 over 16, and then 1 over 16. Which will simplify, okay, to lowest terms. That is 1 over 4, 1 over 8, negative 3 over 16, and 1 over 16. So this is our inverse. Now for the second example, so this is still 2 by 2. So if you follow again yung binigay natin kanina na pattern, no, for the inverse of a 2 by 2 matrix, you will have A inverse equal to 1 all over. So we will multiply muna pag ganyan, pababa, 1 times negative 2 minus, paakyat naman, 1 times negative 2 din, and then times yung matrix natin, pag i-interchange natin yung pwesto ni A and then ni D, tapos si B and C magbabaliktad ng sign. Okay, magiging kung positive magiging negative, kung negative magiging positive siya. So yung negative 2 magiging 2, yung 1 dito magiging negative 1. However, okay, dito sa part na to, no, yung scalar natin, the difference, okay, 1 times negative 2 minus 1 times negative 2 is obviously 0. So A inverse equals 1 over 0 multiplied by this negative 2 to negative 1, 1. Which obviously, okay, hindi pa pwedeng may 0 tayo sa denominator ng fraction because it will be undefined. So, kung ang makukuha natin, okay, na denominator dito is 0, okay, although square matrix to, okay, since 0 yung denominator na to, okay, since AD minus CB, di ba, yun yung ano na yan, okay, AD minus CB is 0, then A, the matrix A that is given, is said to be singular. At ibig sabihin ng singular, walang inverse. Okay? So, it is possible again that if you have a 2 by 2 matrix, okay, or any n by n matrix, okay, ay makita natin na wala siyang inverse. Okay, or walang inverse na nag-exist. Okay, in this case, pag 2 by 2, pag nakita natin na yung denominator, okay, natin dun sa 1 over AD minus BC ay nag-0, okay, then mag-undefined itong portion natin na to, and it means na wala tayong inverse for that particular matrix. Now, there is a general method for us to get the inverse of an nth order matrix. Pag kasi square matrix, tinatawag natin din, no, related to dun sa dimension niya is parang order niya, no, nth order square matrix. So 2 by 2 is second order, 3 by 3 is third order, 4 by 4 is fourth order, and so on. So in general, yung kasing method kanina na pinakita natin is para sa 2 by 2 lang yon. So we cannot use that when you have already a 3 by 3 matrix or a 4 by 4 matrix. So generally, we use the method called adjoining in getting the inverse of a higher order matrix, starting with 3 by 3 paakyat. Although, pwede rin natin itong gamitin kung 2 by 2. Okay, so to find the inverse of an nth order matrix A using the adjoining method, what we do is we construct a matrix of the form A concatenated with in. So pag sinabi mong concatenation, it's like combining, no, okay, two matrices, okay, into a single matrix. So in this case, horizontally ididikit natin, no, parang idudugtong natin si identity matrix I sub n kay A. So kung ano yung dimension ni A, kung ano yung order ni A, yun din yung order ng identity matrix natin. So para siyang augmented matrix, right? And then after that, we will apply elementary row operations, okay, to your matrix AIN. Okay, while until A is transformed to reduced row echelon form. So basically, para tayong nagpo-perform ng Gauss-Jordan reduction dito, okay, yun nga lang, mas marami yung columns kasi natin dito kasi nga IN, okay, yung dinugtong natin kay A. Pero still, okay, the rules apply kung paano tayo nag-reduce or nagka-transform ng isang matrix into RREF. Okay, so we will still follow that. Okay, so kapag naka-RREF na si A, okay, then the resulting matrix, no, should be of the form IN A inverse already. So you see, ang goal natin is actually to transform, no, okay, by performing RREF, okay, by performing row operations rather, yung A natin becomes an identity matrix kasi yun ang ating goal, eh. 'Di ba? Ang RREF ng isang square matrix most of the time ay ano, no, identity matrix. And then yung ating IN, dahil gumagalaw din siya habang ina-apply natin yung row operations natin kay A, pati si IN, no, nagbabago yung elements, it becomes your A inverse already. So to check if what you got is correct, inverse, then pwede nating i-try na i-multiply, okay, the original matrix A and then the inverse that we got after adjoining, after row operations, and we show, okay, that A times A inverse and A inverse times A is equal to an identity matrix. Pag sine-check nyo siya, dapat ititingnan mo yung parehas, okay, hindi lang isa. Kailangan babaliktarin nyo siya, okay, para mapakita nyo talaga na inverse nga kay sila ng bawat isa. But that's just optional, no, yung checking na yan, no, if you have time, you can check. So for example, here you want to find A inverse using adjoining. So you have here a 2 by 2 matrix na pwede nating applyan nung kanina nating method, pero pwede rin nating siyang tingnan, okay, by using adjoining. So our first step is to create the matrix. Ang matrix natin na i-create ay A I2. Bakit I2? Kasi 2 by 2 lang si A. So ano yung itsura ng matrix na yan? So matrix A, 1, negative 2, 2, 3, and then okay, 2 by 2 identity matrix, 1, 0, 0, 1. So 2 rows and then 4 columns. And then we will apply elementary row operations para si A, okay, itong part na to, ito yung goal natin na RREF, ha. Kaya yung part lang na yan, no, si A, ay ma-reduce sa RREF. So kailangan nasa main diagonal puro 1, and then below and above the diagonal ay puro 0. So isi-zero muna natin itong part na to, si 2. ang operation na pwede natin gawin ay row 2 prime is equal to, ipa-partner natin sa row 1, no? So meron tayong 2 and then 1. So ang operation natin ay the old row 2 minus twice your row 1. So i-apply natin yung operation na yan sa buong row 2. Okay? So this one, kay our matrix becomes, of course, the first row will be unchanged. And then i-apply natin yung ating elementary row operation. So you will have here 0. And then you have 3 minus negative 4. So that's 3 plus 4. So you have 7. Tapos you have, sa buong row, so hanggang dun sa dulo. So 0, okay, minus 2, that's negative 2, and then 1 minus 0, that's 1. Then, kailangan maging 1 din itong portion na to, si 7. Kaya ang next operation natin will be row 2 prime equals 1 over 7 row 1. So we'll have here 1, negative 2, 1, 0, 0, 1, negative 2 over 7, 1 over 7. Then lastly, okay, we need to apply another row operation para mag-0 itong portion na to, negative 2. Alright, so our operation to be used to zero out that negative 2, okay, should be R1 prime equals R1 plus twice R2. Kasi ang magka-partner dito is negative 2 and then yung 1. So para mag-0 yung sum niyan, we need to multiply this 1 by positive 2 and then add. Okay? Kasi magka-opposite naman na sila ng sign eh. So we will apply the whole thing, this formula, okay, to the whole first row. So ang mangyari dyan, okay, isa-isahin ko lang, no, para mas malinaw. Okay, yung unang pair, this one and this one, 1 plus 2 times 0. Yung pangalawa, negative 2 plus 2 times 1. Yung pangatlo, 1 plus 2 times negative 2 over 7. Then yung last, 0 plus 2 times 1 over 7. Okay, may fraction kasi siya para, kaya ipapakita natin. No? So 1 plus 2 times 0, that's 1. Ito 0. Yan yung gusto nating ma-zero out. And then you have here 1 plus 2 times negative 2 over 7. So that's 1 minus 4 over 7. Para yung 7 over 7 minus 4 over 7. So that's 3 over 7. And then you have here 2 over 7. So yung ating final form will be, okay, so ito ay elements ng first row, no? So 1, 0, 3 over 7, 2 over 7, and then 0, 1, negative 2 over 7, 1 over 7. So since itong part na to is already an identity matrix, I2, ibig sabihin, tapos na yung ating process. And we will now say that this one here is already your A inverse. Okay, therefore, A inverse equals, okay, so copy lang natin yan, 3 over 7, 2 over 7, negative 2 over 7, and 1 over 7. For number 2, so meron tayo ditong mas malaking dimension, no? So 3 by 3. But we will be using, of course, adjoining. Wala tayo ibang choice. Yung number 1 kanina, pwede nating itry yung method natin ng pagkuha ng 2 by 2, no? Yung shortcut. Pero dito, sa number 2, wala tayo ibang choice, kundi gumamit ng adjoining. Although, later on, ay meron din tayong ibang method determinants naman ang gagamitin, pero later on pa yan. So for now, let's use adjoining for this to find the inverse of this matrix A. So we set up first our concatenated matrix A, and then ang ilalagay natin, dugtong natin sa kanya is I3, kasi 3 by 3 si A. So magiging itsura ng starting matrix natin, 1, negative 1, 0, 1, 0, negative 1, negative 6, 2, 3. Then dudugtong natin si 3 by 3 identity matrix, 0, 1, 0, 0, 0, 1. Then after nyan, apply natin elementary row operations para mag-0 yung below and above the main diagonal, at kailangan din yung main diagonal ni A ay maging puro 1 ang elements. So ang target natin ay ma-0 itong parts na to. Ito muna, tsaka ito. So para ma-0 yan, pwede tayong mag-apply ng row operations, si R2 prime. Okay, ipa-partner natin both, no, second row and third row dun kay row 1. So kung sa row 2 muna tayo, row 2 and row 1 ang magka-partner, ang operation natin will simply be row 2 minus row 1. Kasi pag minus mo si 1 kay 1, 0 na yung magiging sagot natin. And then kung sa row 3 naman, okay, ang ating magiging row operation, so pagsasamahin ko na lang, no, pag-iisahin ko na lang siya ng sulat. Kasi sa row 1 naman natin sila both, no, i-prepare. Okay? So independent naman sila sa bawat isa. So pwede natin siyang ibigay ng isang bagsakan na lang. So sa row 3 prime, para ma-0 natin itong negative 6, ipa-partner natin dito sa row 1. So ang ka-partner niya is yung 1 doon sa row 1. Okay, para ma-0 out siya, yung old value dun sa R3, magpa-plus ako ng 6 times dun sa row 1. So ang basis natin is ito lang, no? Okay, you can check and go back to our discussion sa lecture video on elementary row operations and Gaussian elimination, if you want to refresh, no, kung ano yung kung paano ginagawa yung row operations natin. So itong ating mga elements, no, i-apply natin sa row 2 and row 3 itong ating operations na yan. So we'll have the resulting matrix to be, okay, 1, negative 1, 0. Of course, yung first row hindi siya magagalaw, no? Now for the second row, ma-minus lang natin yung nasa row 2 and then corresponding element sa row 1. 1 minus 1, that's 0. 0 minus negative 1, that's positive 1. Negative 1 minus 0, that's negative 1. 0 minus 1, negative 1. 1 minus 0, that's 1. 0 minus 0, that's 0. And then sa row 3 naman, okay, negative 6 plus 6, you have 0. And then 2 minus 6, that's negative 4. Then you have 3 plus 0, that's 3. Then you have 0 plus 6, you have 6. 0 plus 0, you have 0. And then 1 plus 0, you have 1. Okay, now next natin, okay, na 0 ato natin nasa ilalim nung first leading entry, no, no, nasa first row. Next natin, i-make sure na may leading 1 dun sa second row. Okay naman, may leading 1 naman tayo dito. So ang next natin na target ay ma-0 itong negative 4 natin na yan. So ang next operation natin will be R3 prime equals, so ipapartner natin ngayon itong R3 na to sa R2, hindi na pwede sa R1. So R3 prime is equal to R3 plus 4 times R2. So that will be our next operation. So i-apply natin the whole for the whole row 3. So if we apply this, ang resulting natin na matrix shall be, okay, 1, negative 1, 0. Ang mamamodify natin dito, R3, ano? So, R1 will be unchanged. R2 will also be unchanged. So, 0, okay, plus 0, this is 0. Applying this, no? Negative 4 plus 4, this is 0. 3 plus negative 4, that's negative 1. You have 6 plus negative 4, that's positive 2. 0 plus 4, that's 4. And then 1 plus 0, that's 1. Okay, next step, kailangan yung leading entry, yung leading 1 doon sa ating third row natin ay positive 1. Kaya kailangan natin itong i-multiply by negative 1. So, negative R3. So, our matrix becomes 1, negative 1, 0, 1, 0, 0, 0, 1, negative 1, negative 1, 1, 0, 0, 0, 1, negative 2, negative 4, negative 1. Okay, so dun sa main diagonal natin, mapansin natin meron na tayong 1, 1, and then 1. Okay, so ang next natin na goal is ma-zero out, kasi RREF ang gusto natin, ma-zero out yung mga nasa above the main diagonal. So, next natin na i-zero out will be this. Ito okay na, zero na yung part na yan. So, to zero out this element, ipapartner natin yung nasa row 2 kay row 3. Kasi wala naman ng laman yung row 1, 0 yung nasa row 1 eh. Okay, 0 tong part na to. So, ang pwede mong i-partner dito is this, yung nasa row 3. So, our operation will be R2 prime is equal to R2 plus R3. Kasi negative 1 and 1. So, i-add mo lang, magiging 0 na siya. I-apply mo yung formula na yan sa lahat ng elements ng row 2. So, row 1 as is. Then, pag-addin natin, no? So, 0 plus 0, so that's 0. 1 plus 0, that's 1. Negative 1 plus 1, that's 0. Negative 1 plus negative 2, that's negative 3. 1 plus negative 4, that's negative 3. Oh no. Yeah, that's plus. And then 0 plus negative 1, that's negative 1. Then yung third row will remain unchanged. One more. This one. Okay? So, para ma-zero out yan, ipapartner natin yung row 1 kay row 2. Kasi hindi pwede kay row 3, 0 na lang nandyan eh. So, kay row 2 natin siya ipapartner. Pero dahil yung isa negative 1, yung nasa row 2 positive 1, the operation will simply be row 1 plus row 2. So, i-add lang natin yung nasa row 1 sa nasa row 2. 1 plus 0, that's 1. Negative 1 plus 1, that's 0. 0 plus 0, that's 0. 1 plus negative 3, negative 2. 0 plus negative 3, negative 3. 0 plus negative 1, negative 1. And then, row 2 and row 3 as is yan. Alright, so as you can see now, our matrix A is already reduced to RREF. So this is already an I3. Hence, this part is already our A inverse. Therefore, A inverse is equal to negative 2, negative 3, negative 1, negative 3, negative 3, negative 1, negative 2, negative 4, negative 1.